the problem we're going to solve today is this bad boy here. It is given that the angle theta satisfies the equation sine open bracket 2 theta plus 1/4 pi close bracket equals 3 cos open bracket 2 theta plus 1/4 pi close bracket. Find the value of tan 2 theta. Now, what it is worth considering is what in particular have we been given? What have we been given here? Well, first of all, notice that we have been given a sine and a cos, so we will need to consider what that will allow us to remember. Like sine theta is opposite over hypotenuse, and we've got cos theta, which we know is cos theta is adjacent divided by hypotenuse. There's two terms in here, so we've got a and a b term in here, and in those circumstances that gives us quite a significant clue. We've got 2 theta plus 1/4 pi, 2 theta plus 1/4 pi. So aware of that, we'll be able to suggest that one of them, A, is 2 theta and B is 1/4 pi. Another thing is that we've got sine and cos and cos are related to each other, particularly with regards to tan. We know that tan is related to sine and cos, so we also need to remember that we've got information about tan and the fact that there's a relationship between these three. Also, we're looking at 2 theta, so that's called double angle. So we probably should take a look at the double angle formula going forward. So those are the clues that we've been given to solve this problem. And so that's what we've been given. What do we know? What do we know? So one of the things we definitely know is that we know these are double angle formula here. Here they are. We've got this one here, sine alpha plus beta is sine alpha cos beta plus sine beta cos alpha. And notice the double angle is for the sine, the cos, but particularly there's the tan, which we haven't discussed yet in videos. The tan alpha plus beta is this equation here. And given that the solution is going to be in the form of tan 2 theta, I believe that that is the one that we're probably going to need to concentrate on going forward. That is where we're going to end up tackling. Now, let's just give ourselves a little bit of a recap. If you have not seen the video before on double angle formula, I suggest you might do that. What this represents is that alpha and beta, where there are 2 right angle triangles on top of each other in this manner. Particularly though, you must be aware of the triangles involved. We can create a line that goes down straight here, like so. Notice that this is a right angle triangle. ABC is therefore a right angle triangle. If, for example, I were to perhaps increase the quality of the line, so something like that, and that you can maybe increase the consideration of it being right angle by putting a little square in here. Look at that little square. There is our right angle triangle. So A to C, like so, and up AB. Now, if you're dealing with sine alpha plus beta, then you're looking at the triangle in terms of this opposite and this hypotenuse, because sine theta is opposite over hypotenuse. If you're dealing with cos, you're looking at AC, the adjacent relative to the hypotenuse. But if you're looking at tan, you're looking at the opposite, like so, the opposite line there, and the adjacent line there. They're looking at the ratio of this BC relative to AC. And in the past video, I showed that if you do look at, for example, sine alpha plus beta here, so if you do look at sine alpha plus beta and you take into account this line and this line, then with some steps, if you break down the geometry enough, you can come into this equation here. And that's the last video I've done on double angle formula. If you were to do the same system as that video, or as what was described in that video, but instead do it with opposite and adjacent, then you would come to this formula here. And that's one that I think is worth considering. That's what it represents. It represents this right angle born from two right angle triangles sat on top of each other, like so. 2 right angle triangles sat on top of each other. And it's looking at the relationship between BC and AC for when the 2 angles alpha and beta are together. So that's enough background. Let's start trying to tackle this problem.